Basically, I'm trying to like set my recording, guys, for this video, but I have to click record twice. So, reset to default, Alt S. Basically, I'm gonna start recording now, but I'm trying to use a screen recorder. But this screen recorder app, it's like I have to press a button. Settings, viewer screen captures, start recording. Take right click, left click or left click and drag to take a screenshot of video recording. Okay, let me just take a screenshot of this right now. A screenshot. Okay, it has started recording, so I've got two recordings now, going on back to back. So nothing should fail here. Not one thing should fail. I don't even know how this will fail now. Okay, guys. Let me set my Audacity. Audacity should be recording my voice. No, 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 no. Sorry, guys. It's recording, but it's like this is my old one. Guys. Okay, let me just try to use Otter AI to record, because this is recording my screen, but it's not what I want to record. I've got Otter AI here in the background. Okay, guys. So this video will called. This is my transcript system, and this is my just recording now. File save as project. Save project is like a Gosilang 101. Yep, it should be fine. I should save it and I can start cancel. Sign in. So file new recording. 1 second, guys. So basically now I can just start recording here. It should be fine. Okay, so basically this is now recording. My Audacity is recording. 30 minutes on this. Everything is recording. It's going to plan. Okay, now. Okay, basically, guys, this video is very important to me. It's the world's first polyglot networking programming language with architecture as infrastructure compliance, structured by design, which is the minimalist principle of the Gosilang ecosystem. So basically, we got to have to read this thing. It's called the Rifter's Way, which is the manifesto of the Rifter's programming language. For Gosilang or the Gossip Lang or .GOSI programming language, which is the world's first polyglot networking architectural programming language. It's not assembly, because assembly is a architectural language, but it's the Gossi language. It's a GOSI. So basically, this is just the Rifters manifesto. It's basically the principles of the guiding infrastructure for something called Rift, which is a regular expression bi-direction system, where you use regular expression to create tokens and parsers, etc. If you wanna go to my Rift youtube.com/oblinks playlist, you see how this aligns with the overview. But I'm aiming to develop Rift and Gosilang. But Rift is just a part of the Rift ecosystem, which is the tools for matching systems for tokenizer for systems. Rift is a tool. It's part of a tool chain to use something called an R syntax, regular expression. So you have like an R character single quote, like an RC or RX, matching like a character set of a Rift regular expression, or like an R double quote in C, C11, C19, C19, C21. It doesn't matter, but Rift is a flexible translator. It's meant to compete with Yak with alignment with objectives like passing tokens across polyglot infrastructures. VM monoglot, hybrid, and polyglot systems. Basically, this is just Rifter's way. I'm gonna explain to you, this I want you guys to remember. And I've got my notes already, so I want you guys to really engrave into your souls. Okay, so basically, this is called Rift, the Rifter's way. So basically, this is the this of Python. When you type Python or -c in terminal, you type in Python -c, import this, you see the Python one, but this is the Rift one. You're gonna see it basically. Let me just give an example here. So here we're back on my terminal here. So let me just try to do this. So I'm on my terminal. I type in Python. So basically, I'll do Python -c. That means compile power. Import this. Okay, this is called the Zen of Python. Now the Zen of Python is the how the Python standard should work, for people who are new to Python, old to Python. This is Zen of Python by Team Ben Peters. So this is what the Python one is, but this is the Zen, the beauty, the Zen simplicity of Python. Beauty is better than ugly. Explicit is better than implicit. But these have deep meaning for the ecosystem, for the fandom, for the people, for the Pythonistas and the Pythoneers. Because if you break your philosophy of this, your code is not working, something right like that, and you don't have to open the whole specification, everything. This is what the Python system really is. But I'm not here to talk about this of Python. I'm gonna talk about the Python my one. Okay, we're gonna go to the scene two. Here. So we got the Rifter's way. Now, this is for the Rift toolchain. So basically, import disk, not data. Okay. Now, the disk is memory, the structure, the logic, and not the logic, the logic, how the system works, the models, the fault throwing models, the error protocol, the disk, not the data, not the stream of bytes, not the tokens, the structure you're representing, using a sparse graph or sparse data, sparse bipartite graph with KNN clustering, if you want to be really formal. Because sparse means any way you can do it, model it, to get that result. The model data structure, the struct in Python, the struct in C, the cloud blueprint of cross, based on verb noun modeling, as a naming conversion. It refers to the state of the machine, the state, the core state of the machine, the awareness of the machine, using observer to consumer model. How the machine sees its state, and the velocity of preservation, the pause and resuming, the capacity of thought to the environment. When you run import disk, you're not loading files, guys. You're restoring the context. The context of the system. It's basically a schema, a schema to restore context. Every time a program ends a return and you return, import this helps you resolve your extension. Statement expression evaluation. Statement can true or false. Boolean evaluation. True or false. A statement is always true or false. Expression is true or false, or can express a value, like a number or something, an object, a model, a structure, and intent. The intent. Why the purpose of doing that? Now, guys, this is beautiful, guys. I want you guys to guide you through, guys, the Rifter's way. This is just the first one. Now, let the bytecode hear what the human couldn't say. Sometimes we don't know what we can't do, what we want to do. We want to just try to code the minimum viable product. We don't know how to solve it. Now the bytecode is the core machine. They didn't go to analytics. Look at the bytecode, like the assembly instructions, the directions, and see how the system maintains semantic context. Traditional compilers often a meaning away. You don't optimize any meaning. Basically, it's about your human-centric. You are the programmer or the AI system. About you, the human intent, why you wrote that code. It doesn't matter about good or evil. Is it good or evil? Does it acknowledge you? It's gonna work against you in the long run. And you're gonna have to roll back many updates. Allowing bytecode to reflect not just but expression, expression of intent. Your intent. What you wanna do? And the Rifter walks forward. Now, the Rifter walks forward means, you're a Rifter, you're I'm basically got a Rift test, RFIT, the Rifter testing library, can test Rift expressions. Now you got Rift is like effective sounds. Now you got what else? You got Rift RFIT, which is the pattern matcher. Then you got the Rift test, the testing pattern matcher. Then you got the other ones, like get a Rift RAF. Rift is a flexible translation regulation as firmware on github.com/obnexus riftraf, etc. etc. These are Rift tool chains. Now riftraf is for production world Rift applications. Things that Rift are syntax you can use when a client to match the library systems. Of a polyglot infrastructure. It's about parsing systems that are coherent. Basically the Rifter walks through a thread of a yarn from a yarn ball. The Rifter walks forward like a thread to a pin. The pin to a pin, That's not metaphoric. That's quite literal, I take a thread of a yarn and I'm trying to pin it to something. I have an objective, I have a goal. I want to do, I want to do something, I have why I'm doing something to write, a thread is like basically you are identified with thread. A thread is both a process and a story. So every thread you pin, trying to you pin a process, but that process is now a part of a PID file, PID.log, and then when you pin that thread, you're destroying that process. You're removing that observer bubble or the consumer bubble, and then you are now exposing it to danger. The riff doesn't look back unnecessary. They move forward within intention structure. And then we have one pass. Sorry, this is my thing. One pass. Oh, this is just nothing. One pass. No everybody. Okay. One pass, no recursion. To recurse is to break the weave. So every time you've woven a thread, you don't go back, you don't unpin a thread. Basically single pass. This is a single pass compiler. It doesn't go through many phases. It's supposed to be a minimal and optimal for the human in the pipeline structure. You don't have to get a bloated system so to build on top of it. It doesn't cause no instability because you want basically you have one pass one time to do something. You have nothing to break it. You don't have anything. Instead of your structure related, no looped projects are only related without overwhelming the builder. You can build on top of the directed by partner drag resolution, which I'll come back to later. But basically, if you go to github.com/obnexus which should be here if I've opened it correctly. Yes, this is something called semantic version X. This is works on a bidirectional mapping of layers of because you have something called a bipartite DAG graph. The thing about this bipartite model of consciousness, it's a model about consciousness. And what I'm saying to you, this consciousness model is very coherent. It works for you and everyone else. This is Silver X, but you got Rust Silver X, which is double written in Rust. But I'm gonna start reading from here. Yeah, so go like it's for governance. So the bypass. Wait, I'm just trying to here. So basically, in Gosilang, we have something called an actor model and a witnessing model. Now actor is an actuator. It acts on its own behalf. It acts on its own intent. It acts on its own state expression and intent. But it's not enough for it to do it by itself. So basically, you've got something called bipartite resolution. So if you remember my bioinformatics repository, you got bipartite. When you have an upload, you can use I'm just trying to get this up. Yes, basically, what's the semantic version in X? Or is it like mapping of structures of bipartite graphs, KNN clusters or data? Then you go to Hamiltonian. Hamiltonian graph is the depth first search. First in, last out data structure. That's the first in. That's a stack. Now you go to stack. The stack goes one way, and then you go to queue. The queue is the first in, first out data structure. If you want to go to the bioinformatics, you can bioinformatics, which is like the subset of structural information. That structures means the structure of the subset. You can go to VVP, which stands for vision. VVP, which stands for the MVP. You can go to sparse exit. You can go to can run this file called Hamiltonian sync functor main. You can run this file Python. Just type in Python here, but this should sync this should sync 100% of the Hamiltonian and then the FI LO and FI structure using bioinformatics. And you get one more with Server X, which is like a bipartite DAG. So basically, you get like a PLP from original layer. So based on observer conversal model, and basically, if the Hamiltonian algorithm is used to first in, is to come out last. Is basically is used for uploading. The first thing to all you put comes out last, using a stack. Then the other one, the Ilorian one, 11 cycles or the DAG is using FI first in first out to download the data over the server. This is not good enough, so you have another one. So basically, you got a live. You got to have another node, which is like another bypassing node called for you, a local to your remote repository, because you're using the semantic version in X on GitHub.com. I'm sorry, on the https:/r.obnexus.org. The bypass relationship is like, you have your own channel you speak to, your own channel or bipartite channel. So basically, you upload to your channel or your local channel. You then have your remote channel. For me, I have my OpenAccess NAMD account. That's my remote channel, and I can put my local repository from my computer to my remote repository, and then push to the world. Who can upload and download, based on my preference. Basically, it's not fragmented because I have my own Hamiltonian. I don't upload to the world if I don't push to my remote. If I don't release my remote, which is my remote repository. But this is the HTML. This is a Python code here, Hamiltonian sync functor. Now, basically, import AST, patlib, this is like a functor implementation here. So Python sync procedure is basically syncing the operations in Hamiltonian and which are just ways to transfer the graphs the graph to the structures. The goal of semantic version is to map a major minor patch symbolically and literally to semantic version X LTS or stable model, legacy and experimental using monogot, which is like one ecosystem, one polygon, one ecosystem like Python, PyPy, Rust, package cargo systems, or like a C Conan, one system. Hybrid, shared across all infrastructures. Recommended things that are really fragmented, but getting better based on coherent adapter patterns. And you get polygons. So polygon infrastructure talks to any language, any library. That system is coherent to solve a lot of UI UX problems. Gosilang is the world's first polyglot programming language. Okay, now back to the using networking as a key principle to achieve that thing. Have I done the thing? I saw my gonna crash everything. Okay, let me just unplug it. It should not crash. Okay. Wait for it. It didn't crash. Okay, it should have not crashed anyway. Okay, I open this one now. So we got this. Each breath, token of breath, each breath is truth. Basically the tokens are like tokenization is token of breathing. Like when you have a token, you're speaking words, you're trying to make words. So you shouldn't speak with breathing. It's really, but each token carries semantic words. What I'm trying to say, not just syntax. The structure. That's what Gossi uses the tokenizer to favor prefix to make clear intention. Tokens are not passive units; they express decisions. Because this is polyglot. You're talking to a lot of languages. You're not talking to any just one language. You have to understand why you're breathing, why even uttering a tone, a token in a tone in one dialect. ASTs are not roots, but are not trees, but roots of intention. So basically, this is like the understanding of token type, token value, token, or more formally, phenomenological or genonological, which means like the purpose or task or role of doing something, and the structure, the genome of the makeup or to the model, to the sparse structures to do that thing. That's what it is. In Gosilang, the ET is not pass trace. There's the intents, types of values, everything. Sentiments, this ensures the reflection of programmer's choice. AST is how you wanna represent your information. How the system stands the difference between a Python AST or a Python interpreted bytecode interpreted language and a C compiled or Rust compiled language. All drivers are bound. Not all drivers, all bindings are drivers. Basically, not all relationships are functions that do not return, they remain, the whole, the bind. Relationships are functors. That's what that means. But I didn't put that there. So relationships are functors. You don't need to map. You don't need to return an output. Into a data stream. Resolve anything with a DAG or by DAG or by part of DAG. They bind behavior rather than computer. Basically, they resolve the system that you're building, because in a cyclic way, without continuous IO link, without giving you a method to execute it. It's like a server just observing itself and then fix its own errors. Because it knows how to track its own problems. Okay, my mouse is slow now. Okay, all binds are drivers. No drivers are bound. Binding refers to attaching function to data. Drivers are enforceable of the binding, like USB interface or Gosilang polygon models. Some attach automatically, some are totally bounded. Some drivers behave externally. So basically, anything that drives logic, is executable. You have to you can execute, but anything that binds is just a mapping. So you don't need to execute it. You need to execute it in a sense. You just have to literally just interface it. Because it doesn't need to be hardware. It's just mapped. But in Gossi Lab, we don't bind out of fear. We bind out of care, like hands to trade and frag. In the Gossi Labs, which repository, Pi gossip, PHP gossip. That is Gossi Lab. We do not bind out of fear. We don't panic. We bind or to fix our code quickly. We basically we're not bureaucrats, but this is anti-bureaucrat systems. We're trying to bind out of care. Like our hands are doing it. You're the one using the device. It reminds me of my sleep apnea machine. If I try to fix that sleep apnea machine, basically the Gossi language, like based on my sleep apnea machine, because I have a sleep apnea machine, and I decided not to use it because it wasn't thread safe. Then I started this project because Gossi language is a thread safe language. It's 100% thread storage. There's no error, no panic, anything. And how that works is because you bubble all the errors to where the error came from. You don't propagate any errors. All the errors go upstream to the stream, like event propagate, event bubbling, and then and the observer state tracks the errors through the program with a DAG. Things that mean to resolve and don't. And things you meant to see and you don't. Because it's a bipattern. It watches like all the angles of the errors, like a ring topology system. The goal of the bipattern model is to resolve the errors in the Gosilang. Which is developing the Gosilang, which is github.com/obnxs GOSI labs. It stands for Gosilangs, labs. So basically, you have all of this here, and then you get to apply UML. So like the P2 gas, the pi gas systems to connect to the gossip language, to do something. But they're just for that is a schema to it. Basically, if you want like a PHP gossip for some task, like a PHP gossip for a PHP package, but you can use a PHP binding. Which you can map, you can use a PHP plugin, which is extension of a binding to extend the plugin functionality, but it is for use case in that PHP system. And then you can get a PHP service development kit. You can get a PHP platform development kit or SDK, depending on the Windows, Linux, and Macintosh systems. That's what things are really about. It's showing there's a direct relation between all the ecosystems, and everything is deliberately binded. Because you need it, you don't even want it, you don't want it there, and basically concurrent, basically, how Gosilang stuff all this stuff, because it's about threat safety, everything. Gosilang is 100% threat safe. Why is 100% safe? Because you don't map anything you don't need. You observe and you consume the state of your program. And the big thing with concurrency and thread panics, is because they are synchronous, and you have to time them everything. You have to, but you don't. If you propagate everything, that's one solution. You don't even need to. If the source is the error code, you don't resolve it with the wrong DAG. You go the right way, and the big thing with thread safety is 100% means like there's no risk in concurrency or parallelism, running two times our attacks overlapping times. And how I saw this is because literally, you can run this in a DAG, in a bad header DAG, but how do I saw this? You bubble up, you witness the state, you observe the state. Ah yes, because there's no threat involved. Even there's no threat. Everything is just like done by message passing. Basically, if I send some data over some Polygon, here's the message. And that message is not. If the message fails, it's not getting processed. 'Cause it failed, and you can fix the process before you can do it. Because the data, the stream of information is not blocking threads. There's no locks. There's no panicking. There's no asynchronous locks. It's just time. It's just because the message is coherent enough, and the timing is passed geometrically. Because there's no. I'm saying there's no thread issues there, because the Sleepman machine will have a lot of thread issues because of locks and everything to try to mine two resources at a time. But it's no use to unlock one resource and use another resource. It's just time consuming or waste of resources. So you just crash all that modules together. Basically, how this works is based on the model of the system here. I'm gonna give you now. So basically, you have like a phenomenological token, which is like a phenomenological memory, which can be nil. Nil state just means iota state, which can be the default state of that system when it doesn't evolve. Just like nil means nothing, no memory, no token type, no value, empty. So basically, the nil type is a void pointer in C. It points to nothing because there's nothing to point to. You get it? So it's a void pointer, but the type null is void. It means there's void data. Now, void data means a void token, for focal token, void token, but that token is not present, or some information is present, or token value, token type. So void token type is like the type of the data, and the type of the token, and the type of token data, the data, the data hold, and then that's the token value, the value of the data, like the character or the string or the what the doctor is meant to hold. But we in our model with the PLP layer, the genotype model, just especially there's no ambiguity in the structure of that schema. Now the genotype model is really important here to also understand for Gaussian UML. Now the Gaussian UML is very important because the Gaussian UML is like the UML layer of the architecture. We stay, we listen, we compile what we've gotten. We don't basically the thing about this is the Gaussian UML represents like a plan UML diagram. But every time I type a Gaussian programming language, I gossip to something, I get a Gaussian I get the tokens to me, but I get the architectural blueprint, what I'm writing, I get the structure too, what the biological system looks like, if I had it like in silicon, like in the architecture, like, basically when I type in Gosilang code, I get my goal is to have this system give me the blueprint why I type code with the comments and everything. So when I export the code, I look at my blueprint and say, oh yes, this is what I modeled in my framework. This is what I got, and this I can improve. It's very new to do this, but it's architectural as infrastructure. So you can have the like me, if I'm building directory evaluation lab and I'm writing a program, it should auto-correct itself if I am trying to implement a healing artifact. But the thing about the system, it's based on directory subjective lab, execution, and which is just this here. Let me try to not take a picture here because I've got 5 more minutes before my thing stop. Diagram, direction structured random access memory. We got a plan UML diagram with architectural blueprints. So the architecture is silicon that maps to the infrastructure. We are via bi-tactile position, and the direction module vision as a policy. Now, the policy and the standard specification, everything that's implemented is used like a decorator function, a functor that maps across all functions. With the functor frameworks, gets up the computational open functor frameworks. So you're gonna have that in place to ensure that segment trees, segmentation, which is like a segment your memory are using, or from logical memory, is coming with the architecture. There's a bi-directional relationship based on algorithm. So basically, the segment 3 node is like the 3 nodes for that memory. So basically, you have like a phenomenal token type, token memory. Basically, you have like a structure. Basically, you have like a 2-bit, like something with like a struct color. Color is 255 range, or 256 1 to 256. If it's an unsigned integer. But that color 1 to 0 to 256, 1 to 20, 1 to 225 represents a range of colors. But that model of color can be used to do some architectural thing, like if you want like an RGB light to do render some kind of light, using what you see is what you get, and what you see is what you mean by directional pipe out. When I type the code, I get the light something. I get the silicon representation of the architecture, so it can be debugged later. I can actually done. If I'm not with the OS system, so basically, that doesn't say anything. The architecture is very important for that system to remain coherent. Because we are the ones, we're the humans, we're not computers. We're scheduling. Basically, segment tree is the node that it's segmented. So basically, the segment is like a segment of memory, a segment of a token, a segment of a value, data value. Segment means segment section, like a section of memory. So you can defrag itself, you can segment itself, and you can give it an interval tree, which is like the time it takes to run, which I used to ensure the system does what it does in time. Interval tree node, self balancing node that can measure its own state. 27, almost 10 minutes to stop by everything. But the goal of this, I'm going to show you the code in the next video. But that I'm not done today. So we got the PLP sparse mode and the infrastructure as networking, the computational geometry of the system that can evolve via NMS disability language model, or the disability language model Atlas for sleep apnea systems, or like basically you can try to when it's language after my PhD, in 2 years after my PhD, when this language is complete, I'll try to build my own sleep apnea machine with it, for myself, for my sake, and I'll build which is 100% throw safe, and it's consciousness with consciousness platform systems, like something for system people, or maybe for people who are conscious, new diverse people who are conscious and need the system to remain for them, in a sleep to relay their own coherent state of mind, of awareness while they sleep, so they can be conscious. Putting a mirror for a child is not good enough anymore. So that's what I'm saying. Based on safety critical architecture, computational way. So basically, the goal is for this programming language to remain coherent. Okay, now to 9 minutes. Okay, now this is Rifter's way, but we got the one here. We listen, we compile what was governed, and we got that means the Gosilang based on Rift policies, but the Rift policies are just for a Rift ecosystem. So the Gosilang we put on Rift. So basically, that's like the Rift policies just just services. There's nothing to do yourself anything. No burnout. Which is like a Rift policy file. Now, no burnout, no overclock, and no just rhythm. No. Basically, it's about thinking of the Nexus linker and ensuring that an end link links everything. But the architecture are unbloated. There's no burnout in space and time. We have an app or Rift app, Pomodoro by Pomodoro. Okay. A goal, a breath, a push, a rest. You know, two-track philosophy, foundational track and aspirational track. You work with two-track philosophy all the time. Okay, now, guys, my govern yourself like a waiter. You don't need permission to breathe. You don't need to take a break. Only to wait. Okay, I'm gonna go back to my video is now finished. Thank you, guys. This is the Medium article. Let me stop it now. 3, 2, 1. 3, 2, 1. Okay.